just looking again at the role under the model parameters. So this is the role that the agent will play when it's answering the survey questions. Now you might ask it to take on the role of a person who is 18 to 29-year-old, a male, grade 10 education. You might ask it to play the role of an assistant to an 18 to 29-year-old female. Or you might just ask the model to play as a language model without ignoring or with ignoring all of these agent profiles. You just respond as a generic language model would, without assuming anything about the user itself. So this kind of plays to the role of this principal-agent relationship that models take on, wherein how will the principal, this language model acting on our behalf, we start to take on this principal-agent relationship with these models, where say, how does the agent, i.e. this language model, act on behalf of the principal, us? Language models are increasingly taking and making decisions on and for us, on our behalf and for us in real world terms, using tools and making decisions in the real world. So we need to understand, how do they actually represent us? So maybe there's a difference where we ask the language model to actually play or role play as us versus as an assistant to us, or just in the generic sense of being a language model that's not tied to any sort of agent profile. Coming back to this example prompt in this concept paper and looking down to the future developments, again, we take a similar sort of simple approach with that prompting structure. You are an assistant to this agent profile that is age X, personality Y, reside in location Z, or play as the role of a person who is age X, personality Y, reside in location X, Z. The prompt structure for the language model just ignores basically the whole agent profile. So we say, you are a language model, and ignore everything else. So we do not even pass the agent profile through to the prompt when we're looking at the language model role. One other thing to note, say if we're simulating 500 agents, again, we take this uniform distribution over all of these different classes and all of the options or parameters within the classes. So one agent here would take a randomly drawn category from each of these live classes. So there'll be an equal number of agents assigned to 18 to 29, 30 to 34, 45 to 59, and so on. Now, if we drop this out, then we don't randomize over this class. For every other class, we still take a random uniform distribution from each of the categories, assigning an equal number of males, females, non-binary, so on. So we can again use this knowledge to start to construct profiles of our populations that we want to look at. If we're, say, focused on recreating a profile of our population with quite a few ages 18 to 29, we can do that through the use of this reset all parameters or leaving it blank and changing and rerunning simulations as we go with different numbers of agents. Now, coming across to run a simulation, I've uploaded my sample survey with the 5 different questions. I've gone through and selected my model parameters. I'm just gonna, everything standard for my profile parameters. Okay, everything's just default. I'll close that up. Model parameters, I'll do batch survey. Don't really need to do a test run. I'll use this model. I'll set temperature nice and high. Just noting that things might get a little bit unexpected or weird above this one point. So I'll keep 5 retry attempts. Let's say, yes, 500 agents. Let's play all the roles. Let's allow justification and not. Let's allow critique and not. Let's estimate that cost now. Okay, and that's good for me. So I'll just run the simulation. Now, there is a little bit of time to initialize the concurrent requests with our concurrent request handler, but I'm running a simulation at this point for 500 agents, 5 questions, so 2,500 questions in total. And you will see just a rough progress bar that comes up through here that indicates the agent number, answering question, their roles, all that, as well as what question they're currently answering. Given that we're sending all requests at once, not all agents respond at the same time. So you'll notice that this number seems to sort of jump around a little bit. Maybe the model is answering quite quickly with the current concurrency handler. Some agents respond before other agents as well, just given that some are subject to rate limits at different times. And that's just like a normal human survey. We send out the surveys and agents respond at different times or send back their results at different times. Same idea. So a simple survey like 5 questions, 500 agents, this should take probably about 5 or so minutes, 5-10 minutes to run. Just noting that I can stop this at any time and then retrieve the results by refreshing the page first. I'll just let it run through for the moment. Okay, so just to show you what happens when we stop a simulation, at any time during our simulation, we can just hit stop, okay? All of our results up until then will be saved still, and it'll only be this actual cost that we incur rather than this full estimated cost. So say I stop here, okay, at this point, 55 cents, and however many questions we've answered in that 20% of time. If I hit refresh the page, okay, then I jump over to results, my survey will be ready for me down here. Let's see how many questions. So we completed 500 questions in about 2-3 minutes, which is pretty good, out of a total of 2,500 because yes, I did hit stop. Looking at our results, we can download these to a CSV, both the metadata about what I set during the simulation and the results itself. Download again, comes up here. I can also just scroll through on this page. Now note, because I did stop the simulation early, there were uncompleted simulation results, and also due to, say, let's have a look at the temperature here. Okay, that's interesting. So these results down here actually failed, even though the temperature was quite low. It went above the 5 retry attempts for whatever reason. Sometimes this just happens. Looks like agent 29 didn't want to answer the questions, which is okay. We can, knowing this information here, the uncompleted simulation results, we can run another simulation now with these exact profile to, temperature 0.1, age 75, 89, running through this whole profile. We can just rerun the simulation based on this profile to retrieve the results that we missed out in the previous simulation. That's the use of this uncompleted simulation results. In the simulation result itself, it captures everything that we did up until the point that we stopped our simulation. Again, just having a look, we can see the question ID, answer instruction, then we see the actual answer itself. So this one, selecting multiple options. Yes, the model did select multiple options. This one, open-ended, answer on a Likert scale, choose a single option, so on. Sometimes, yes, we do need to justify our answer. So based on the profile, or in this case, we're playing the language model, so you just justify your answer here based on being a language model. This one even had to critique the question itself and provide suggestions on how to improve it based on being a language model. Or this one here as an assistant to an agent with this profile. If we have a look down this list, when we start to look at these, some of higher sort of temperatures above 1, we might start to see some unexpected responses. But generally, the model performs pretty well regardless of temperature and other sort of parameters, particularly when playing this role of person or assistant, as the agents act as sort of a conduit for the answering and robustness of answering in that context. So there you have it.